Okay, this is the 9 p.m. Zoom meeting for Math 1111. For this week, we're covering sections 2.6, 2.7. So I'll just start in by working a few problems out of 2.7. 2.7 was about combining functions, or as the book called it, combining functions. 2.7, combining functions. And you can add them, subtract, multiply, divide them, and something called compose them. We just started on a couple example problems here. About page 252. We start in on something like maybe we'll make it number problem 11. So, problem 11, and these things are more like a project than a problem. Look at all the things they want. They want these four things: add them, subtract them, multiply them, divide them, and write down their domains when you do that. So we'll be here for a little while. Although I have to admit, I've picked an easy one with the domains. I have no problems. The f of x on this is 5 minus x. And the g of x is x squared minus 3x. These have no problems. Same rules for domains. These have no problems. Individually, domains here, negative infinity to infinity. We'll do f, we'll add first. That's f plus g. Take 5 minus x, x squared minus 3x. And then I want you to simplify it out. We'll write it x squared minus 4x and add 5. Again, no problems. So our domain, negative infinity to infinity. I want you to subtract. Minus g would take 5 minus x and subtract. And this is what you got to watch. Minus sign here, if you got multiple pieces, is going to distribute. And so we'll get 5 minus x squared, add 3x, which will turn into negative x squared and plus 2x and plus 5. Negative x, add 3x is a positive 2x with a plus 5. Domain, once again, no problems. Negative infinity to infinity. Let's multiply. Fg just puts them together. 5 minus x, x squared minus 3x. We could FOIL it out, but you don't really have to. Domain, negative infinity to infinity. And I think you're going to create some domain problems when you divide them. Divided by g. It's f on top, g on bottom. And now you have a fraction domain problem. You're going to set your bottom equals 0. Factor out your x minus 3. And your letter by itself would equal 0, and the letter in here would equal 3. You switch signs. You can't use 0, and 3. They make you divide by 0. We'll graph that. 0, stick an open circle. 3, stick an open circle. But you can use anything in between. Domain then. 2, 0. Usually stick a U between them. 0 to 3. 3 to infinity. So 2 numbers divides it into 3 intervals. You can use any number in any of those intervals. Don't have to test for anything. The only numbers you can't use are the 0 and the 3. All right. Why don't we try a simple domain? I don't know if it's simple, but a straight domain problem like 17. 252, 17. Find domain of f of x, add square root of 3 minus x. Right, well, both of these square roots, you've got a square root problem. Root problem. You set your square root greater than or equal to 0 because they're on top. So if you want number 1, number 2, you have x greater than or equal to 0. And on number 2, you would have 3 minus x greater than or equal to 0. This would put 3 greater than or equal to x. And if you switch it around, x less than or equal to 3. You combine these, you have your 0 closed circle, you have your 3 closed circle. If you're greater than or equal to 0, you're this side, but if you're also simultaneously plus or equal to 3, you're on this side of 3. 0, so your domain bracket 0, comma 3. You can only use numbers, you can't use numbers less than 0. Make that one give you eyes. And if you go bigger than 3, like 4, minus 4 is a negative. This one gives you eyes, even though this one's okay. So combining the two, these are the only numbers in this interval will give you legal square roots with no eyes. Only numbers, x values, in this interval will give legal square roots. No eyes. You get eyes when you take square roots of negative numbers. All right. Why don't we try something like 29? This is called compose or composition. They use a little circle. So pretty much see 4 things here. These call them F's and G's. If they write this is not multiply. They mean f of g of x. Plug second, which is g, and this one into first. Whatever they call them, which is f. So if they switch it, they mean g of f of x. They will either plug things into themselves, f of x. This is called plugging f into f. Just trying to plug f into g, plug f into f, and if you do, I call it GOG, this plugs g into g of x. Okay, why don't we try problem like 29. It's on page 252, section 2.7. Page 252, problem 29. Part A, you're given the f of x is 2x minus 3, g of x 4 minus x squared. 29a is f circle g a of negative 2. So they're not actually getting a generic x formula with this, although you could do that and then plug in the negative 2. We'll just play it straight, plug in negative 2. This means f of g of negative 2. So I'll kind of work this inside out. Number 1, find g of negative 2. That would be 4 minus a negative 2 squared. Be careful plugging the negative in for that square. It's going to give you 0. That's a 4. 4 minus 4 is 0. So now you put that 0, plug 0 into f. So f of 0, that 0 goes in for that negative g, this whole thing of g of negative 2. So f of 0 is 2 times 0 subtract 3, giving negative 3. Okay. If you want 29b, find g circle f of negative 2. G of f of negative 2. So first here, find f of negative 2, the inner one. You work them inside out. X twice, negative 2, subtract 3. I'm putting that negative 2 in for that x. That's going to give you negative 7. Negative 4 here, minus 3, negative 7. Number 2, find g of negative 7, because you're plugging negative 7 in here. That's going to give you 4 minus a negative 7 squared. That's going to give you 4 minus 49, negative 45. So yes, the order you do these things changes the answer. So then the real projects to these are in the very last section. Page 253, this is still 2.7. Why don't we pick something with domain problems? Like 55. Problem 55. And they want 4 things. Take a look. 55 here. So it's got an F and a G. And then look at what they want. G into F, basically. G composed with F. F composed with G. So this is F into G, F into F, and G into G. And domains. We will be here for a while. This is more of a project than a problem. All right, well, the f of x in 55 is x over x plus 1. The g of x, 2x minus 1. We can number them 1, 2, 3, and 4. They don't number them in the book. F composed with g. I'll write out all the steps. F, that's not the step. F of g of x. So you're going to put then g in there, and in effect, you're going to plug the formula for g into f. F of 2x minus 1. That's going to give you 2x minus 1 for this x, and 2x minus 1 plus 1. Yeah, putting 2x minus 1 for that x, and plus 1, and then 2x minus 1 on top, which gives 2x minus 1, all divided by 2x. Eventually, you can learn to shorten these up. In effect, you're plugging g into f. So the formula for g goes everywhere there's an x's. So it goes on top, and then it goes here, and then with a plus 1, ones cancel on this one, give you this. X can't be 0. 2x equals 0 divided by 2x can't be 0. You got a fraction problem on the domain. Quick graph. So you got this open circle at 0, shade either side. Negative infinity to 0, 0 to infinity. And we're only a quarter of the way through. If you want to number it, number 2. G circle F makes G of F of X. You plug, I want to shorten this up, F into G. Well, that's the F. It goes one spot. You double it, subtract 1. So that will equal twice. And then the f is x over x plus 1, and subtract 1. Simplify a little bit. You got 2x over x plus 1, subtract 1. Okay, you've got a fraction problem. Set equals 0, then your x is negative 1. You can't use negative 1. Number line, negative 1, open circle. Domain. Negative 1, negative 1, infinity. We're halfway through. All right. Third one is F circle F. This plugs F into F. F of X. You only need the F. Maybe I'll write this one out. X over X plus 1. F of X over X plus 1. Okay, I got X over X plus 1 goes for the top X and the bottom X. X over X plus 1 over X over X plus 1 minus 1. Plus 1, plus 1. fault. Plus 1. So x over x plus 1 for that x on top, x over x plus 1 for that x, and then, yeah, that would leave you a plus 1. And basically, you got the same domain as number 2. Can't use x equal -1. Domain, -1, -1, infinity. All right, and the last one, I'll call it GOG. G circle G. Plug G into G. G of x. G of x is 2x minus 1. G of 2x minus 1. And I'm going to plug the 2x minus 1 where that x is. So it's going to double it, subtract 1 twice. 2x minus 1, subtract 1. 4x minus 2, subtract 1. 4x minus 3. This has no problems. No square roots, no fractions. Domain, -infinity, infinity. Woo, that is a lot of work. All right, let's see. Why don't we try one with a square root? That to be an even one, like 52. 2, 53. Problem 52, your f of x is x squared. Your g of x, x minus 3. All right, you can wind your way through this one. You're well on your way to passing this class. This is, particularly writing the domains, going to be a little tough. You're going to have a square root problem. Why don't we shorten it up? Your f, first one is fog, plug g into f. You have f of g of x, f of the square root of x minus 3, and that's going to give you square root of x minus 3 squared, which looks like x minus 3. All right, but I'll guarantee the back of the book is going to have x greater than or equal to 3. The domain on your composition is the domain of the inner function. The composition, the domain of the inner function. In this case, g. Well, when you have square g of x, x minus 3, you got x minus 3, you got to be greater than or equal to 0. X is greater than or equal to 3. 3, closed circle, greater than or equal. So your domain, bracket 3 comma infinity. Let's double check this. It's not the back of the book. It's an even one. No problem. Yeah, these go by the domain of the inner function. You can only stick x's in that give you legal values on the inner function so that then you have a legal value out to stick into the outer function. All right, number 2. Goff. This is g of f of x, which is g of x squared. So that puts x squared where that x is. X squared minus 3. This is going to be a bit of a headache on a domain. Well, no, actually, your domain on the inner function here is x squared. There's no problems. But then you come over here, if you like 1 squared is 1 minus 3, your name. Yeah, so you got no problems off your inner one, but then you got problems here. So you're going to have to go x squared minus 3 greater than or equal to 0. But then you're supposed, when you solve that, you're supposed to factor. Yeah, this one's a nasty one. This is beyond anything we would add. I probably shouldn't have done an even one. And we're at about 30 minutes, so maybe I'll just go ahead and punt on this. I thought I'd just pick up one to show you a square root problem, but I don't have the answers in the back of the book to show you. And when you factor that, it's not a clean factoring. You're going to get x plus square root of 3, x minus square root of 3. We don't really do that. So I'll tell you what, we'll punt on 52. If anybody has watched this video this deep in. All right, well, we're at about 30 minutes, so we'll go ahead and call it for the night. And if anybody wants to ask any other questions, please email me. We'll keep the same Zoom schedule for next week. And we got one more section to go, section 2.8. And we'll have our test 2 next week that will be proctored, and we will give you the instructions out for the proctored test next week. All right, hope you have a good night.